you will see in your packet there's nowhere to go. The next page in your packet is review for the test. All right, so you know where the review is at least, right? Because this year, myself and Miss Venezia, who's the other honors geometry teacher, we decided to add a new section to this, constructions, and it seems like it's been forever since we talked about Centroid, Circumcenter. Remember those? All right, and those are on the test again. All right, so today was a good day not only to review those points and what they mean, how they're formed, what they do, but also how to construct them. So that is why you're getting a new piece of the packet. On your assignment sheet, it says to finish this packet. So whatever we don't finish is your responsibility over the weekend. Finish this one I'm handing out now, which we'll get through most of it. Okay. I just want to give you guys a heads up. I am not teaching anything new today. There are no new concepts. This is old constructions and how to apply them to our points of concurrency. That's it. All right, so what I'm trying to tell you is you're going to teach me today. All right, you're going to do basically the notes and you're just going to show me, remind me how to do things. Now, so there's no excuses on Monday or for the test for that matter. I don't know when you're going to end up doing this assignment. Could be late Sunday night, Monday on the bus, whenever. I will just want to remind you, because we are going to do a lot of constructions today. If you forget any of the steps, that we have your back covered here. On our website on Aspen, there is a folder that says Regents Review, construction folder, and there's a link to a YouTube videos that has every single construction we do this year, remember, including the ones I'm going to show you today. Hey, there's altitudes and orthocenters. Oh, there's the centroid. Look at that. There's a median. All right, so you are in center. So you are covered here in case you forget the steps. All right. All right, let's start this thing. First thing we're going to review, constructing a midpoint and a perpendicular bisector. So what you guys need to do with your straight edge right now is just draw a line segment. Draw a line segment for me. Okay. Review. How do I do a perpendicular bisector? Or find the same construction. Perpendicular bisector, find the midpoint, same construction. How's that happening? Where am I putting my compass? Again, I'm on. Here you go. Take over. Yep. Make sure my compass is correct. And then let's make a decent size arc, everybody. And from here, again, you guys are taking over today. Where do I go from here? Other endpoint. Leave your compass opening the same. Other endpoint. Yep. You are going to take your straight edge, line it up. Now, as you draw this line in through your 2 points of intersection, what is this line called that you are now drawing in with your straight edge? That is the perpendicular bisector. Right here, that line is your perpendicular bisector. That perpendicular bisector also finds you the midpoint. Everyone see where the midpoint is? Same construction. I don't need to do anything else. There's your midpoint. If you want to put markings on your diagram, sure, go ahead, but start thinking in your mind right now, where could I use this construction and all the vocabulary we talked about this unit? Because this is going to come up again. It went to a midpoint, perpendicular bisectors. Start thinking about that. Everyone all good? Next review one. Can you draw a perpendicular line through a point that's not on the line? So take your straight edge, draw yourself a line for me. And give me a point right now that is not on the line. Anywhere not on the line. Doesn't matter where it is, just can't be on the line. All right, the last construction we did is not going to cut it here because it'll be perpendicular, but it may not go through P. Probably not. So anybody want to refresh my memory on how to do this construction? Because it's not the same one as above. How do I do this one? Perpendicular through P. Put my compass point where? On the point, my point P, wherever your point is. And what's my goal right now? Arc intersects how many times? And if I can't get it to intersect twice, got a solution? Either direction or both, yep. Okay, from here, go to each point of intersection. I usually do these two away from your point, because if you go towards your point, they may actually intersect at that point, and you don't want that. You want two arcs that intersect away from the point. And hopefully they intersect, they line up right with P. And then you can draw your perpendicular line in. So start thinking, where could I use this now? What have I talked about this unit where something's perpendicular to a side? Where could I use this? All good so far. One more review one. Bisector. So freehand and angle, go ahead. You don't need your compass for this one, just freehand and angle. Make it look somewhat decent. All right, review with me. Review, how do I bisect your angle? Come on, let's go. Come on, use a big boy word. Thank you. Put your compass point on your vertex. Make an arc that intersects in both rays. From here. Aaron? Yep. would I want to use this construction in this unit in particular? All right, we all good on the review ones? Okay, because now what you're going to see is, all right, I'm going to ask you for one of those special points we talked about this unit. Which one of these constructions would help me? Okay, which one of these three constructions would help me? All right, here we go. First one. Help me find the centroid of the triangle ABC. Centroid. So we may need to go back to our old packet because I know it's been a while. Centroid. Here we go. What are we thinking about with centroid? Not the special fact. I want to know how it's formed. Okay, let's go. 5, how is the centroid formed? The medians. Wait a second. I don't think we've ever done a median construction in here. No big deal. What do you know about a median? Because this is not going to be a new construction. Vertice 2. Do you know how to find a midpoint? Okay, here we go. Let's do the median from A to BC first. And please stay with me on this one because I'm going to show you a little tips here and there about how you don't have to have so many arc marks and lines. All right, so go ahead, do your construction to do the midpoint of BC. Open up your compass, more than half the length. We get the deal. Please do not draw your line in, though, yet, because we need to talk. So everyone has their first 2 arcs, or getting them down. Now, help me out. When I line up my straight edge and draw that line through, what's that line called? What's that line called that I would draw through if I line this up? Perpendicular bisector. Do I need that here? No. That's just an extra line that's just going to make more of a mess probably on your paper. All you need is line up your straight edge and mark what? Where the midpoint is. I don't need the full line. I don't need it. All right? It's not useful here. It's just going to make more mess on your paper. So line up your straight edge, give a little mark, tick mark, point, whatever you want to put there. Not mathematical at all that I'm doing this. There we go, fine. There's the midpoint. How do you draw the median in now? Take your straight edge and line up your midpoint and your vertice A. That's how to construct a midpoint, or a median, excuse me. So there's one median. How are we going to find the centroid, though? That's the intersection of all the medians, right? Now we know how many medians are in every triangle. 3. Do I need all 3, though? No, if you're construction A game, you have an A game for constructions, you only need to do 2. All right, so I know this is awkward, but you're going to have to go to the right or to the left now and do the same thing. You can always turn your paper too, remember. You don't have to tilt, crooked. I see kids over here, they're all bent over backwards in their chair. Hey, boss, just turn your paper. Okay. Everyone all right? Centroid. Questions on your centroid? I have a question. What's so special about it? Here we go. Review. It cuts the median into 2 to 1. So ready, if I put X here, the other part of the median, 2X. We all good here? One more challenge question, honors kids. Will the centroid always be located inside the triangle? Is it possible or impossible for it to be on the outside? Is it always on the inside, or are there certain instances you could envision that it would be on the outside? How's it formed? Medians. Where are the medians always? Inside the triangle, right? So the centroids always be inside. Circumcenter. Here we go. Little review first. Circumcenter. What are we thinking about with circumcenter? Intersection of my 4. Intersection of my. There we go. Same construction we did above, but now I'm going to draw the line through and see where those lines intersect each other. And this one just gets nuts. Nope, sign out, take the pass. How's our circumcenters matching up there? Okay, let's keep talking before we go on to the next one. What's the special fact about the circumcenter? Equidistant from the... If it's equidistant from the vertices, that means you can check if you found the correct point or not. Take your compass right now. Put your point on the what you think is the circumcenter, and then put it on the vertice. Does that distance match to the other vertices from the circumcenter? Pretty easy check. Pretty easy check if you found the right point as the circumcenter. Okay? And where did this circumcenter end up? Where, as far as the triangle goes? Outside. So yeah, circumcenter could be outside, inside, all right, versus the centroid, which has to be inside. We all good so far? This is the last one I'm going to do with you, and I'm going to go on, let you go on your own. This is probably the least favorite of students, and that is trying to find the orthocenter. Okay, here we go. Orthocenter. Tell me a little something about it. It is the intersection of 8 altitudes. All right. I have never done with you constructing an altitude, which shouldn't be a big deal. Describe to me what an altitude is. 20. I almost had it full class without calling it. 29. What's an altitude? Perfect. Good timing. 14. From a vertice, a perpendicular line. From a vertice, a perpendicular line. That's all we're doing, right? Is a construction for the point not on the line. So we're going to take our compass. We'll do A first because after A gets a little nuts. I want to do this all together. I learned my lesson last class. So I go from point A, make an arc that intersects twice. It should happen. Oops. Have to get it at just the right opening. There we go. And then go from each point of intersection. You can draw the full line in. You could just draw it to the opposite side for the altitude. That's your call. All good so far. Because now it might get a little crazy and you might get a little uncomfortable, which is fine. I'm going to go from C to AB now. C to AB. I'm going to draw the altitude from vertice C to side AB. So as I put my compass on C, I notice a problem when I try to draw that arc across. And anybody else experiencing the same problem? I only can get it intersect once. No matter how far or how narrow I open up my compass, it's only going to intersect once. So what do you got for me? Extend your side. Yep. So I'm going to extend AB in one or both directions. Doesn't matter. With my straight edge. And now hopefully I can get it to intersect in 2 spots. I think I can here. There we go. Mine's going to go off the paper, of course. So I go to each point of intersection. Try to get these 2 to intersect. Oh, that's up here. Yep, I don't know how to bring this all down. Shoot. Mine's going to intersect way up here. Sorry, guys. What I'm trying to get to you guys is that you're going to have to extend your first altitude up so they intersect. They'll intersect outside the triangle. They should intersect outside the triangle, right above or to the right of A. Yep, hopefully you guys are experiencing right above A. They should be intersecting. And that's what happens when you have an obtuse triangle. You're going to have an altitude outside. You're fine. Looks good. And there is no special fact about the orthocenter, so you have to rely on your construction ability to make sure you got it in the right spot. The only thing you could say about the orthocenter, it could be located outside or it could be located inside. Again, what type of triangle, or it's going to be located outside? Obtuse, which is what this triangle is. And look where it ended up. Anybody remember where it lands on a right triangle? Intersection of the two legs, yes. Which, if you look at this triangle must be pretty close to a right triangle, yes? Because it enters, the orthocenter is pretty darn close to A for most of you. Everyone all good? Because I'm done. So you're going to do the in-center. In-center is what? The angle bisectors. So I don't think I have to review that one with you. And then you're going to answer some algebra, multiple choice, fill in the blank questions for me. They are still on Aspen. The answer key is still on Aspen. Get after it. You got plenty of time.